Alrighty, let's take a look at this question. So, this was on the 2016 diploma, and when it was, 47% of the province got it right. So, let's take a look. Might be a bit harder. So, polynomial function, p of x equals blah, blah, blah. But when you see that, you notice something different about that equation. Notice there's a k. Okay, we'll come back to that. All right, keep reading. Two of the zeros are -1 and -2. It can be determined that the largest zero of this function to the nearest tenth. Okay, so zeros are just x-intercepts, or the values of the function, or values that when y is 0, or will satisfy the equation if it's all equal to 0. Okay, so if there is a missing parameter in a polynomial equation like that, the idea is to use remainder theorem / factor theorem to find that missing parameter. So if one of the zeros is, I'm just going to use -1 because it's smaller, is -1, then we can go p at -1 and sub that in for x, and that means that would equal the remainder, and if it's a 0, that means the remainder is 0. Or you can think of it like a point on a graph. That would be an x-intercept, so -1, 0. You put 0 in for y, -1 in for x. You can think of it that way too. It's also a factor theorem. Okay, so we put -1 in for x. I'm just going to quickly write that down. That would be a -10. Ooh, lots of negatives. You got to watch that. And plus k, and then times -1. Okay, when we simplify this, we should be able to solve for k. So that first term is going to be -2. Second term will be +3. Because when you have an odd exponent on -1, the result will be -1. When it's even, it will be +1. So that's how I'm kind of jumping through this fairly quickly, but you can put it in the calculator as well. It's 21 and then minus k. Okay, since k is negative, I'm going to add k to the other side and then finish figuring out what these add to. So -2 plus 3, 1, and then plus 10 is 11. Minus 21 is going to be -10. So k would be -10. I better check that again just to make sure. -23, +13. Yep, we're good. Okay, now that we have k, we actually know our polynomial function. So let's write that down. It would be 2x to the 5th plus 3x to the 4th minus 10x cubed minus 21x squared minus 10x. Now, at this point, you could totally just put it in the graphing calculator, and the largest x-intercept, meaning the one furthest to the right, would be your solution. And that is by far the easiest way. But we could practice some polynomial stuff by maybe factoring it by hand and then looking at each of the x-intercepts that way. So factoring it by hand, we know two of the zeros, so we could simply, actually we're going to need a third zero, aren't we? Because it's, oh no, we're not. Actually, we could factor out an x to begin with. Notice there's the greatest common factor of x. So let's factor that out. That's why they gave us the two zeros. Because when you start with a polynomial, whatever the degree is, you have to get it down to a quadratic, x squared, in order to factor it normally, not with synthetic division after that. So if we factor an x out, then we have x to the 4. We have two different zeros, so we do synthetic twice, and that would bring us down to x squared. Okay, so now we just do synthetic on the part in the brackets. So 2, 3, -10, -21. You take the coefficients, in case you were wondering, of all of those terms. And if you are missing a term of like an order of degree, notice it goes, the exponents are 4, 3, 2, 1, and then 0. If you're missing one of those, you would have to write a 0 in its place, like a placeholder. Okay, outside here, we're going to start with -1 as our first thing we're going to divide in there. I'm using the adding way of synthetic, so carry the 2 down, multiply -1 times 2, and then add, and then multiply, add, etc. And at the end, you should end up with 0, because we knew it was had a remainder of 0. All right, now we're just going to go again. I'll do a different color and use the other 0 that was given, the -2. Carry this down to -4, -3, 6, -5, 10, -1. Oh, sorry, that is not -1. That is 0. Alrighty. Okay, so now we have finally down to a quadratic. So that would be 2x squared minus 3x minus 5. And we factor that normally. So multiplies to 2x squared would be 2x and x, multiplies to 5. Could be 1 and 5 or 5 and 1. So let's think about this. The 2 outside, inside has to have a difference of 3. So I'm going to put the 5 here and the 1 here because this would be 2x, this would be 5x. That gives you a difference of 3. And we want -3, so the 5 has to be negative. All right, now finally we have p of x equals x bracket. And we turn these things we divided back into factors. So x equals -1 would become x plus 1. We just add 1 to both sides to do that. And then same thing with the x equals -2. And then the two factors we got when we factor that. Oh, x plus 1 is actually squared because there's 2 of them. So I'll write it like that. So that would be a multiplicity of 2, but that's another video. All right, now to find the zeros, you set each factor equal to 0. X plus 1 equals 0. X plus 2, don't forget the x in front equals 0 as well. That's important. And then you solve each one. So x equals -1, x equals -2. We knew about those ones already. This one, 2x equals 5, divide by 2, x equals 5 over 2. All right, let's see what's bigger. Well, those are negatives, so not that one. So x equals 5 over 2 would be the biggest one. How do they want that? To the nearest tenth. Okay, so divide that and you would get x equals 2.5 would be your answer to the nearest tenth. Alrighty, hope that helped.